Hello class. Today we're going to do a little bit of STAAR review. We're going to actually review three particular concepts today, ending with mean absolute deviation. The first concept we're going to look at is angles within parallel lines. So what I'd like for you to do, try to think back to when we did a lesson over this, several lessons over this, and we had to find all the missing angles. So what I'd like for you to do is pause the video and see if you can remember what to do. Number your paper from 1 to 20 and find the missing angles for me. Okay, so let's see how you did. Okay, there's a couple things that you need to remember about the angles within parallel lines. There are some key vocabulary words that we talked about. This angle right here is what we call a given angle. Here's another given angle. In order to find angles within parallel lines along a transversal, which is what this line and this line right here are called, they're called transversals because they cut across two other lines. There are some certain angle relationships that are formed. Take, for example, this angle and this angle are what we call vertical angles, so they're congruent. This angle, the 62, and the angle 1 are called supplementary angles because if you put these two angles together, you get 180 degrees. And that's what we're looking for whenever we're dealing with these particular figures. There's some other angles that are important as well, like 62 and angle 4. They're what we call corresponding angles. Okay, and there's some other ones. So let's see if we can find all the missing pieces. So the first thing I want to find is angle 1. And the way you do that is you take your calculator and do 62 minus 180. Or excuse me, 180 minus 62. And you find out that angle 1 is 118 degrees. Now, because the given angle is 62, I know this angle 2 is also going to be 62 degrees. So I'm going to write 62 right there. And because angle 1 is 118, then I know angle 3 is also going to be 118. Now what happens is these four angles right here are going to travel down this transversal. And these four angles down here will be the same exact ones. Okay, so that means angle 10 will be 62. Angle 1 will be 118. Angle 12 is going to be 62. And angle 13 is going to be 118. Now, I couldn't travel them down to the middle section because there's another type of relationship that's going on there. We'll get to those in just a moment. Okay, so we found all the angles that we can find immediately off of that transversal. Now let's come down here to this other set of given angles and see if we can find all the angles related to 120. Well, 19, since it's a vertical angle, it's going to be the same thing, 120. Now I need to find angle 18. Well, 120 and this 18 are what we call supplementary angles. So we just take the 120, subtract from 180, and you find out that, oh, not 68, what am I doing there? That you find out that angle 18 is 60 degrees. I think I saw that 8 and put an 8. So then angle 20 is going to be 60 degrees also. Now again, these four angles here are going to travel up this transversal, and they're going to find themselves right there. So angle 14 is going to be 120 because it corresponds to the given angle. Angle 15 is going to be 60. Angle 16 is going to be 120, and angle 17 is going to be 60. Now we've got to work with this center section right here. Now there's a couple that we can find pretty easily. So if you look at this given angle right here of 62 and angle 4, they're actually the same angle. They're what we call corresponding angles. So it's a 62 degree angle. And then it has a vertical angle, angle 7 is also 62. Now you can do the same thing with angle 6. Is this angle 15 and this angle 6? They're also corresponding angles. They're going to be the same. So this one's going to be 60, and this one's going to be 60. Now we got to find angle 5 and angle 8. Well, if you pay real close attention, angle 5 and 8 are actually an angle that is inside this triangle. So if I know one angle is 62 and one angle is 60, well, if we add that together, you're going to get 122. Okay, so if we take 180 and subtract 122 from it, you should end up with 100, let's see, 62, let me see if I can, 62 plus 60, you get a 122, and you subtract that from 180, and you end up with this angle here being 58 degrees. So if angle 5 is 58, then angle 8 is also 58 degrees. And you've now found every single one of those angles. Now, why do we need to know that? Well, because STAAR is going to ask you some questions that are like this. It says in each diagram, line K is parallel to line L, and line T intersects lines K and L. Based on the diagrams, which statement is true? Okay, so if you look at these particular examples, because what we want to get to is, what is the measure of angle X? Well, we know angle 113, that angle right there, and this angle right here are the same. Those are what we call alternate exterior angles. So this one's on the left side of the transversal. This one's on the right side, so that makes the alternate, and they are what we call exterior angles. These two right here are the same thing. The 127s are alternate exteriors, and they're congruent. This 90 and this 90 are congruent. So what could we say about this 79 and this X degrees? Well, hopefully you could say that it's also 79 degrees. So now if we look at our answer choices, and it says, the value of X is 79 because the two angles shown in each diagram are congruent. That's a true statement. So then it says the value is 101. Well, where'd you get 101? Well, if you look at the 79 and the angle right next to it, that's going to be 101, okay? So its corresponding angle would be there. Okay, the value of X is greater than 90 because the two angles shown in each diagram are obtuse angles. Well, 79 is not obtuse, it's acute, okay? The value of X is 11 because the two angles shown in each diagram are complementary. Well, remember, complementary means two angles that equal 90 degrees. So in other words, they're going to make a right angle. These two angles are what we call supplementary angles, okay? So that's the reason why we have to understand those lines within parallel, or angles within parallel lines. Next one, scientific notation. Okay, so if you remember in scientific notation, if we've got big numbers, like this first one, like this number right here, it's going to get a positive exponent. If you have a small number like this one right here, it doesn't really look small, but because of where the decimal is, it is small, it's going to get a negative exponent. Okay, so what I'd like for you to do is think back, pause the video, and rewrite each of the numbers as their corresponding ones. If they're in standard, write them in scientific. If they're in scientific, write them in standard. Let's see if you can remember how to do that. Okay, so let's see how you did. So this first one, if you remember correctly, okay, what we're going to do is we need to write this number in such a way that it has one number to the left of the decimal point. Okay, and the value of that number has to be between 1 and 10. Okay, so where would I put my decimal in this number? Well, the first thing we do is we look for significant digits. So this number has 3 significant digits, 5, 0, and 6. What I mean by significant is there's no longer zeros, just a bunch of zeros. Okay, so the 506, all 3 of those are significant. Okay, all these zeros here, they become not, I mean, they're important, but the whole purpose of scientific notation is to get rid of the zeros, okay, and to represent them a different way. So where can I put my decimal so that this number is between 1 and 10? So could my decimal go here? No. Could my decimal go here? No. Could my decimal go here? Yes. Could my decimal go here? No. The only place the decimal can go is right there. So you write it as 5.06 and then times 10. And then we ask ourselves one question. How many places are between where my decimal was and where I moved my decimal to? So we got 1, 2, 3, 4, 5, 6, 7, 8, 9. It's a big number, so it gets a positive exponent. So it's 5.06 times 10 to the 9th. Okay, the other one, there are, again, 3 significant digits, 3, 0, 2. Where do I need my decimal to go so that it's between 1 and 10? Right here, and then times 10 to the, oops, that was a horrible 10. Let me try that again. Times 10, and then now we look for the exponent. So we ask ourselves, where was the decimal? Where did I move it to? How many places in between? 1, 2, 3, 4, 5, 6, 7. But this is a small number, so it's a negative negative exponent. So big numbers get positive exponents, small numbers get negative exponents. Okay, so this next one, we got to go the other direction. So we're basically going to take this decimal right here and move it 8 places. So what I like to do is take my significant digits, write them down, and think about where my decimal is going to go. Okay, I'm going to move it 8 places. Now, is this going to be a big number or small number? Well, since the exponent's positive, it's going to be a big number, so I'm going to move my decimal 8 places to the right. 1, 2, 3, 4, 5, 6, 7, 8. And you'll notice there's 5 empty places there. So that means we got to add 5 zeros to our number. So we add 5 zeros, and we place commas where they're supposed to be. Okay, and that's how you'd write that. Okay, so we got to remember that this 8 does not mean add 8 zeros. It means move the decimal 8 places. Okay, so this next number is going to be a small number, so it's going to be a decimal value. So I'm going to write my significant number. Now, where's my decimal at in this number right now? It's right here. And I need to move it 12 places. Now, since it's going to be small, I got to move the decimal that direction. Okay, so I need to move it 12 places to the left. So one of those places is around the 2. So then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 more get us 12 places altogether. So that means I moved it around the 2 once for one of those numbers, and I had to add 11 zeros. So this particular number would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Throw a 0 in the front. So now from where that decimal was to where the decimal is, there's 12 places. That's scientific notation. Now, why do we need to know that? For questions like this. Okay, the mass of a textbook is approximately 0.00165 metric ton. How is this number written in scientific notation? Well, we know that it's a small number, so it's going to have a negative exponent. We ask, where's my decimal at now? Where do I want it to be? Well, in between the 165, I need it to be so that its value is between 1 and 10. So 0.165, we're going to put it between the 1 and the 6. How many places is that? That's 3. So there's only one answer that it can be. Now, the reason why we're going over scientific notation is scientific notation was not on this last test. The last time STAAR gave the STAAR test, there was no scientific notation on it. So that means this year, there's more than likely going to be scientific notation. So we've got to make sure that we understand that. Okay. Then the last thing I want us to talk about, mean absolute deviation. Mean absolute deviation is one of the easiest things in the world to do. It's just boring and cumbersome. So you got to remember, mean is average. Absolute value means it's got to be a positive distance, positive number. And deviation is the distance from the center. So there's 3 steps that we follow when we're dealing with mean absolute deviation. Find the mean of all the values. So you take all the numbers, add them all up, and divide by how many you had. Step number 2, find the positive distance each value is from the mean. So you take that mean and you take each data value and you subtract them. Okay? If you go one direction, you'll always get the same type of number, but you always want it to be positive. So if you get a negative value, just don't write the negative down. And then you find the mean of those differences. That's the mean absolute deviation. So if I gave you a problem like this, you'd first, come back here. You'd first write the data down. 3, 6, 6, 7, 8, 11, 15, 16. So then what you're going to do is you're going to take all of those numbers, you're going to add them all up. 3 plus 6 plus 6 plus 7 plus 8 plus 11 plus 15 plus 16. I'm using the calculator on the outside. Okay, and you get 72. So then you're going to divide that by 1, 2, 3, 4, 5, 6, 7, 8. Divide by 8. You end up with 9 for your mean. Now what you're going to do is you're going to take each one of those values and subtract. So 3 minus 9 is going to give you negative 6. Okay, so negative 6. Negative 6. But what we want is the positive value. So you write 6. 6 minus 9 is negative 3. So I'm going to take the positive value. 6 minus 9, negative 3. So 3. 7 minus 9, negative 2. So I take the positive. 8 minus 9, negative 1. 1. 11 minus 9, 2. 2. 15 minus 9, 6. And 16 minus 9, 7. Now what you're going to do, once you've done that, you're going to take all these positive values, add them up, and find their average, their mean. So 6 plus 3 plus 3 plus 2 plus 1 plus 2 plus 6 plus 7. Enter. You get 30. And again, we're going to divide that by 8 because there's 8 numbers, and you end up with 3.75. That is the mean absolute deviation of that set of data. And that's all there is to it. Again, why do we have to do this? Well, because you get questions like this on the STAAR test. Over the last several years, there's been at least one question over mean absolute deviation. Okay, so when you look at these numbers right here, you know the mean's got to be somewhere around 40. Okay, looking at the smallest number being 32, or 28, sorry, and the biggest number being 51, you're going to get an average somewhere around 40. Okay, so if you look at these answer choices, are there some answer choices you could automatically eliminate? Well, you could eliminate A and C, because those are going to be like means. That's about where the number is going to be, and one of those will actually be the mean of that data set. Okay, so what we're looking for then is it going to be B or D? And that's what you'd have to figure out. Okay, so what you're going to do for your assignment today is you're going to practice mean absolute deviation. I'm going to give you two sets of data, and I want you to fill in the blanks. So you're going to take the data and you're going to write 115, 105, 108, 120, 100, 125. You're going to find the mean. You're going to write them down right here. You're going to find the difference right here. Then you're going to find the positive value of that. Then you're going to add them up. You're going to, and this one, count just means that there's 6 numbers. And then you're going to find the mean absolute deviation. You're going to do that for both sets of data. Okay? So that's all we're doing today. We've reviewed 3 concepts. We've reviewed angles within parallel lines, because you're going to have questions like this. We've reviewed scientific notation, because you're going to have questions like this. And I can guarantee you're going to have at least one question over mean absolute deviation on that STAAR test. Okay? So I'll talk to you later. Until next time, see ya.